Hi everyone. So today we are going to look at service accounts, Taints and Tolerance, and node affinity. So let's start. Service accounts. Service accounts. There are two types of accounts in Kubernetes: user accounts used by the humans, and service accounts used by the application. So let's say you want to collect some metrics for your application running in the cluster, then you can have a Prometheus and you can configure it using service account. So that's the use of service account. So when application talks to Kubernetes API, it needs to be authenticated. This is done by using service account. So that's the service account. Default service account. Kubernetes automatically creates a token used for authentication and store it in as a secret object. So this is deprecated, but I have kept to over here to let me know that what was the cons of using this method of creating a token and store it as a secret object. Uh, so yeah, so every namespace has a default service account. Okay, so service account it is at a namespace level. If you don't specify a service account in pod specs, the default one is used. So default one, let me see if get set. Oops. Okay, I think the mini cube has not been started yet. Started. By the way, the website I was building is now updated with the latest documentation. So service account, which we are referring right now, it's also up. So I think it's looking good so far. If you have any suggestion, please let me know. I want to create a map for it. So this is the map, and you can go to each and node over here and read about that particular node. Okay, but in Obsidian, it feels more. It has vibe. The Obsidian map graph view has a vibe, but still, it's okay. The website. Yes. So now get. Okay, so this is the default one, and let's start a pod. Okay. Let's create. Let's run a pod with Nginx image. Okay. It's equal to Nginx. So now pod is created, and let's get all the pod. So container is been creating. It takes time, I guess. Can we describe it? Describe pod, my pod. So this is the place where it mounts, where run secrets Kubernetes are / service account. Okay. This is where the service account is mounted on the pod. If we So default one is used. So this is default one, and to avoid, and if we do a get service, then this is the default one which is mounted over here. Okay. If we don't specify, then the service account is mounted. Default one is mounted. To avoid automatic token mount in specs section, you can avoid automatic token mount in specs section. To change the wording of this. Okay. You can use this, so it will not automatically mount the service account token. Yes, Kubernetes mount token, a default service in the pod, and the token is available at this. Okay, so we can look at that token. We can first do ls, so you can see slash secrets list of io slash service account. Use Okay, so this is the directory where it is mounted. When we can use token to get the token to specify the cat command over here. Okay, and that dash dash also. Okay, now we got the token, and we can go to the website CWT.io. It is taking time. Okay, so this is the token over here. Namespace default node is minikube and pod is this default one. Okay, so that's how you get the token and see the details in that. So limitation of a default account, it has very limited permissions, and to use a custom service account, specify it in a pod specs. So if you want to use your service account, custom service account, you can create one service account, and inside the pod specification, you can have this fit. And now changes in Kubernetes 1 and dot 2 dot 1.22. So older tokens had no expiry, and uh, were not audience bound and were stored in secret per service account. So there were, if you see over here, now it has expiry time and all. But earlier the tokens used to be not time bound and were not audience bound. So now it is audience bound. If you see over here, it is audience bound. So audience who or what token is intended for. So it is now audience bound and were stored in a secret per service account. So uh, like if you have 10 service, then you will need a 10 secret, okay, object. So it posed a secret and scalability issue, and Kubernetes added a token request API which generates time bound, audience bound, and object bound tokens. So token is created now on the fly and mounted as a projected volume and not store it as in a secret. Okay, if you see over here in describe the command for pod, this is a projected volume. So a volume that contains injected data from multiple sources. So earlier it used to be a secret, but now it is a projected. So that was the change in 1.22. Changes in Kubernetes 1.24. So service accounts no longer create secrets automatically. So service account used to create a secret object, and inside the secret object they used to create the token, which was this, right, which is deprecated now. But now it no longer creates the secret automatically. You can manually, like, what if you want to have old behavior? You can manually create a secret like this. This is the secret definition. I should also mention the API version over here. Okay, so using annotations, you can create a service account and do that as well. But it is not a recommended way unless you are absolutely necessary, as these tokens are non-expiry. So these tokens are non-expiry, and you know the risk which it poses. Okay? So the best practice is to use the API, token request API, and avoid creating non-expiry token secrets. This is the way you can create it, the token for a service account. Actually, I in exam, what I will we can use essay over here. So every stroke in exam is valuable, right? So I need to have like a cheat sheet for the aliases, like service account. For service account, it is SA. For service is SVC. For deployment, it's deploy. For pod is PO. So I need to have that. So this was the overall service account. Okay, let's go to Taints and tolerations. So this is very like interesting topic. So imagine this. In my room there was painting lit recently, so I can relate it very much. So you have a room freshly painted with a strong smell, okay, and people find the smell unbearable, so they avoid entering. When the painting was finished in my room, there were fumes coming out of it, and my eyes were burning. So I avoided entering into that. So I can relate it this. That's why I use this example. Painter use masks so they can tolerate it and still go in. Okay, so imagine this. So in Kubernetes, the room is a node and people is pods. The smell is a taint, and tolerant to the smell is a toleration. Okay, which is set to a pod, and this is taint is set to a node. Okay, so the idea is to have control of what pod goes into which node, but with a limitation that we will discuss. So tents are like saying this room smells. Don't come unless you can tolerate it. And toleration are like people that says I'm okay with the smell. I can enter it. Okay. So tents effect no schedule. So this will not allow anyone unless they tolerate the smell. So they don't allow anyone, as in pods will not be scheduled on that particular node. Okay, prefer no schedule. Try to not allow anyone, but okay if there is a no choice. So in certain scenarios, uh, like if the all other nodes have high resource utilization, and the scheduler cannot schedule the pod on the node, then it can schedule on this node. Okay, if the tenant selected is prefer no schedule. Kick out people already inside and don't allow new ones unless they can handle it. So no execute. It's like if you tend that uh, node with this particular tend effect, then you can evict the people. But sorry for this example. Don't kick anyone. Say politely. So kick means evict. I should evict out. Evict. Let's be kick only. So tolerations, to add toleration to a pod, we can specify toleration in a pod specs. Okay, so key is room, operator is equal, value is strong and small, and effect is no schedule. So if this particular pod we have particular pod has this toleration, then it can be scheduled on that particular node. Okay. So default behavior, if not a node and exists, scheduler schedule the pods across the nodes evenly. Add a tent room equal to strong smell colon no schedule to one of the pods. So you can add a tent to uh, a node, and you can add the toleration level for that tent in a pod. And if now, like if you have four nodes or four pods, then if goes to node that has this particular tent, okay, it will not be scheduled. If pod B goes to that particular node which have this tent, then it can be scheduled. Okay, another other will be get blocked. Okay, so that's how the flow works. Master nodes by default has a tent, so no pod gets there. Okay, and it's not generally a good practice to schedule your workloads on master nodes. Okay. Also, keep in mind that tents do not guarantee placement. They just block the pods without toleration. Okay. So if no restriction is on other node, a tolerating pod can go on there too. Okay, so if we have nodes and in particular one nodes we have kept a tent. Okay, uh, and also we have put a toleration on one of the pod, but that pod can go to other pod as well, go to other node as well, which has no tent. Okay, so this doesn't guarantee the placement. They just block the pod without toleration. So to tent a node, you can use this particular command. And let's look at node affinity now. Node affinity is the way to control the pod, where a pod should be placed by attracting it to a certain nodes, and by attracting certain nodes based on the labels. Okay. Node affinity configuration. This is the node affinity configurations, and the simplest way to do way to control your pod is node selector. We can just define node selector in the pod specification. But if you want advanced level of feature kind of thing, then you can opt for node affinity. So yeah, that's the point. I didn't mention it over here, but yeah, good to know. Node selector can be used. It is the simplest way to schedule your control your pods where it will be placed. So next is node affinity, like this particular sentence, which is very long. Required during scheduling, ignored during execution. So during this is the type of node affinity, and we will discuss it. But for now, the key is size and operator. You can have in not exist values what the pod is looking for, like large or medium. So if you have like a pod, if you have large number of nodes, okay, and you want to schedule it, the pod want to schedule the pod want to schedule it on like the large ones only, the nodes which has large label, then you can do it with here. So node affinity, types of node affinity required during scheduling, ignored during execution. So during scheduling, pod must land on the matching nodes. Okay, and during execution, pods continues running if the node label changes later. So if a pod is continuously running, and if the admin cube admin changes the label of that node, it will be still running it. Okay? And during scheduling, the scheduler will place the node on that matching node only. And if the matching node like it cannot schedule on that, it will not. It will be in the pending state. Okay. Prefer during scheduling, ignore during execution. So during scheduling, pod tries to match to the pods try to go to matching node, but will schedule elsewhere in certain scenarios. Okay, so scenarios may be like a heavy resource utilization on the other nodes, on the nodes. So yeah, that is. And during execution, pod continues to run even if the node label changes later. Node affinity versus tents and tolerance. So node affinity is like pulling pods towards the node, and tents and tolerance pushes the pod away from the node. Okay, so this is the difference between node affinity and tents and tolerance. So yeah, that's all. So tents and tolerance are also node affinities also. Yeah, bye everyone.